Beneath the grandeur of Rome's marble temples and sprawling amphitheaters lies a story of ingenuity, ambition, and relentless pursuit of progress. The ancient Romans, renowned for their military prowess and political acumen, were also master engineers. Their innovations not only shaped the world of their time, but have left a profound legacy that still influences modern engineering today. At the heart of Roman engineering lay a philosophy to conquer nature, to bend it to the will of civilization, and to ensure the prosperity and comfort of Rome's people. This ethos would drive them to create structures and systems that seemed almost impossible for their era. But how did they achieve such feats, and what innovations stand as testaments to their genius? The story begins with roads. Rome's network of roads was legendary, stretching over 50,000 miles at the height of the empire. These roads were not just pathways connecting cities, they were lifelines for commerce, communication, and military movement. The phrase, "all roads lead to Rome," was no mere boast. It was a reflection of a meticulously planned infrastructure. Roman engineers designed roads with a multi-layered approach. The base was made of large stones, topped with gravel and sand, and finally paved with tightly fitted stones. This construction ensured durability, with many segments of Roman roads still visible today, nearly 2 millennia later. The roads were cambered, allowing rainwater to run off into ditches, preventing erosion and maintaining their integrity through the centuries. But the Romans did not stop at roads. Their ambition extended to the mastery of water, bringing it where it was needed, controlling its flow, and harnessing its power. The aqueducts of Rome remain among the most iconic symbols of their engineering expertise. These soaring stone arches carried fresh water from distant springs and mountains into the heart of cities, supporting populations that would otherwise have been impossible. Roman aqueducts relied on a subtle but precise use of gravity, with channels sloping gently over miles to maintain a steady flow. The engineers used a tool called a chorobates, a kind of level, to ensure the gradient was perfect, allowing water to travel immense distances without pumps. The Aqua Appia, built in 312 BCE, was the first of Rome's aqueducts, but many would follow, each more ambitious than the last, culminating in masterpieces like the Aqua Claudia and the Aqua Marcia. The water that flowed through these aqueducts didn't just supply fountains and baths. It was integral to nearly every aspect of Roman urban life. Public baths, known as thermae, were social hubs and marvels of design. Inside, water was heated using an ingenious system called the hypocaust. Floors were raised on pillars, and hot air from furnaces would circulate beneath, warming the rooms above. This early form of central heating not only created comfortable bathing environments, but also demonstrated the Roman commitment to luxury and technological advancement. Roman mastery over concrete was another cornerstone of their engineering prowess. Unlike earlier civilizations, which relied on stone or sun-baked bricks, the Romans developed a form of concrete that could set underwater, a game-changer for construction. This hydraulic concrete, made from a mixture of lime and volcanic ash called pozzolana, allowed them to build harbors, piers, and monumental structures with unprecedented strength and durability. The Pantheon's dome, still the largest unreinforced concrete dome in the world, stands as a testament to this innovation. Its oculus, the circular opening at the top, not only admits light but also reduces the weight of the structure, showcasing a profound understanding of both materials and physics. Bridges were another arena where Roman engineering left an indelible mark. The Romans constructed over 1,000 stone bridges throughout their empire, many of which remain in use today. Their secret lay in the use of the arch, a structure that distributes weight efficiently and stands strong against the test of time. The Pons Fabricius, built in 62 BCE, still spans the Tiber River in Rome, its graceful arches a silent witness to centuries of history. Roman bridges were not just functional, they were also statements of power and permanence, often adorned with inscriptions and statues to celebrate the achievements of emperors and generals. Urban planning was yet another field transformed by Roman innovation. The Romans understood the importance of order and utility in the design of their cities. Streets were laid out in a grid pattern, intersecting at right angles to create efficient traffic flow and easy navigation. At the center stood the Forum, a public square that was the heart of civic life, surrounded by temples, basilicas, and markets. The Romans also pioneered the use of multi-story apartment buildings, known as insulae, to house the growing urban population. These structures often featured shops on the ground floor and living quarters above, foreshadowing the mixed-use buildings common in modern cities. Sanitation was an area where Roman engineering set standards unrivaled for centuries. The Cloaca Maxima, Rome's Great Sewer, was originally constructed in the 6th century BCE and expanded over the years into a vast network that drained wastewater from the city into the Tiber River. Covered drains and underground channels crisscrossed the city, keeping streets dry and reducing the spread of disease. Public latrines, often elaborately decorated, provided communal sanitation facilities, demonstrating a sophisticated understanding of public health. The Romans were also adept at constructing monumental public buildings. The Colosseum, perhaps the most famous of all Roman structures, was a marvel of both architecture and engineering. Its elliptical design allowed for efficient crowd movement, with 80 entrances and a vast system of corridors and staircases. The use of concrete and a complex system of vaults and arches enabled the construction of tiered seating for over 50,000 spectators. The Colosseum even featured a retractable awning, the velarium, to shield the audience from the sun, a feat of engineering that required coordination from hundreds of sailors trained to deploy the massive canvas. In addition to these public works, the Romans excelled in military engineering. Their armies marched with portable kits for constructing fortified camps, complete with ditches, ramparts, and palisades. Siege engines such as ballistae and onagers, capable of hurling massive projectiles, were standard equipment. The Romans also built temporary bridges and causeways to cross rivers during campaigns, often under the most challenging conditions. Julius Caesar's bridge over the Rhine, constructed in just 10 days, stands as a legendary example of Roman engineering speed and audacity. Harbors and ports were another domain where Roman engineering shone. The port of Ostia, Rome's principal harbor, featured massive breakwaters and artificial basins protected by concrete structures extending into the sea. The harbor at Caesarea Maritima, built by Herod the Great with Roman expertise, was the largest artificial harbor of its time, employing hydraulic concrete to create underwater foundations. The Romans were not content with merely constructing. They sought to standardize and systematize their innovations. They developed comprehensive manuals on architecture and engineering, the most famous of which is Vitruvius's De Architectura. Written in the 1st century BCE, this 10-volume treatise covered everything from materials and construction techniques to acoustics and aesthetics. Vitruvius's work became the foundation for architectural education in the Western world, influencing generations of builders from the Renaissance to the present day. Beyond the grand projects, Roman engineering found its way into everyday life. The use of lead pipes for water distribution, the construction of vaulted ceilings for strength and beauty, and the development of glass windows to admit light while keeping out the elements. All these innovations improved the quality of life for Roman citizens. Even the humble milestone, marking distances along the roads, reflected a commitment to order and efficiency. Yet, Roman engineering was not without its limits and challenges. The extensive use of lead in plumbing, for example, would later be recognized as a health hazard. Large-scale projects often required vast resources and labor, sometimes supplied by slaves or conquered peoples. The maintenance of such a sprawling infrastructure demanded continual investment and organization, which proved increasingly difficult as the empire expanded and eventually declined. Despite these challenges, the legacy of Roman engineering endures. Many of their innovations were lost or neglected during the turbulent centuries that followed the fall of the Western Roman Empire, but they would be rediscovered and emulated during the Renaissance and beyond. The principles of the arch, the dome, and the vault became cornerstones of Western architecture. Roman roads laid the groundwork for modern highways, and the very concept of public infrastructure as a tool for civilization would inspire generations of planners and builders, Perhaps most importantly, Roman engineering reflects a spirit of pragmatism and ambition, a belief that human ingenuity, applied systematically and with determination, can overcome the obstacles of nature and circumstance. The ruins of Roman aqueducts and amphitheaters stand today not just as reminders of a vanished world, but as monuments to the enduring power of innovation. As we move through modern cities, cross bridges, drive on highways, or turn on a tap to draw fresh water, we are, in many ways, inheritors of the Roman tradition. Their innovations remind us that progress is built on the foundations of those who came before, and that the pursuit of excellence, in engineering as in life, is a journey without end. The story of ancient Roman engineering is one of vision and perseverance, of problems met with solutions that would echo through the ages. It is a story of how concrete, arches, and aqueducts helped create an empire, and how their legacy continues to shape our world, stone by stone, road by road, innovation by innovation.